Hello, my dear students. Now we are having question number 15. A current loop of arbitrary shape lie in uniform magnetic field B show that the net magnetic force acting on the loop is equal to 0. So if we are taking any kind of arbitrary loop, let us consider we are taking one square loop. So one square loop, and this square loop we are having four sides. Okay, let us consider this side A, B, okay, B, C, C, D and D, A of equal length. So this length is equal to L. This is also equal to L. Okay, square. And if we are considering current as anti-clockwise direction, and the magnetic field B, which is into the plane of this paper, so we are considering this magnetic field B vector, which is into the plane of this paper. So the in this complete space, the magnetic field will be into the plane of paper. Now, if you are finding the force, we are considering force different direction here. Okay, so that we can represent the force in vector form also. So we are considering this x-axis and y-axis. Okay, so that we can easily uh, consider the direction. We easily represent the direction of force. Now, if we are talking about the force on AB, okay, in vector form. So the current I, length L, and magnetic field B, and what is the direction? So you can find the direction using Fleming left hand rule. Okay, this is direction of magnetic field which is into the plane of paper. This is direction of flow of current. So the force will be upward direction, means positive y direction. Okay, this is the direction of force on AB. Okay, so it can consider as a J cap. Okay, now if you are talking the force on BC, okay, BC vector. So again current I, length L, magnetic field B. Now the magnetic field inward and current flowing in upward direction. So force will be in negative I direction. Okay, so the force will be in negative I direction. So you can write this minus I cap. Okay. Now same as it is if we are finding the force on CD. Okay, CD. So current I, length L, magnetic field B. Now Fleming left hand rule. This is the direction of current. This is the magnetic field. Force will be downward direction, means minus J cap. Okay. And in the end, we are finding the force on the DA. So current I, okay, length L, magnetic field B. Now this is the direction magnetic field. Current is flowing in downward. So magnetic field will be positive x-axis. So you can use I cap. Okay, now if you are taking the net force on the loop, so you can write force on the loop. Okay, that is the net force on AB plus force on BC, okay, plus force on CD plus force on DA. Okay, so definitely all this force will cancel out. The first force is ILB J cap. The second force is minus ILB I cap. Okay, third force is minus ILB J cap, and the last is minus, sorry, plus ILB I cap. So this 2 will cancel out. This J cap also will cancel out, and net force you are taking, you are finding it is equal to 0. So you can say it, if you are taking any kind of arbitrary loop, the net force on this loop when it is placed in magnetic field, uniform magnetic field, it is equal to 0.